this website. Joinpd.com, please. So, not much I can do for you. All right, ladies and gentlemen. Jonathan.
No, but she said that they could have been.
Susan, Leslie, Brianna, Jordan, Virginia, yes, Natalie, thank you. Mark Alvin. Yes. All right. Okay, please keep in mind, ladies and gentlemen, they are keeping track of attendance. They told us yesterday at our meeting that at last week, Friday, they checked attendance and there were 11 people who were tardy 4 times already, and they were going to be getting detention starting today during lunch. Okay? So if you are tardy 4 times, you end up with a lunch detention from 4 times total. So far in a week.
So 4 times in a week.
4 times in the trimester. When you hit your 4th tardy in the trimester, and by the way, if you're tardy 4 times for one class and 4 times for another and 4 times for another, that's each class that you'll get assigned a detention for.
So what if people start skipping instead of being tardy?
Well, they said they have a plan. Well, if they start skipping, then you're
Now, what if they
absent.
say, damn, I'm tardy and I'm not even going to go, so I'm going to detention?
Wait, that's dumb. Wait, they're gonna put you in detention during class?
No, during our lunch hour. So
So what if you leave? So that we can't.
you won't be able to.
What if you're tardy 1 minute and you're about to go up and like you're like, oh, it's going to be my 4th. I'm not going to go.
Then you're marked absent, and then you
like
start.
You have 3 tardies and then you're like tardy for the 4th, but you're like, damn, I don't want detention. So you skip that class.
So what are you going to do? You're going to skip that class for the rest of the semester?
No, just as long as you're not late. Every time you're late, you just skip it.
Oh, so then you'll get a truancy citation for missing so many classes.
They just send the warning, but they never send a ticket.
Okay. Well, I'll let them know that that's what you guys think, and we'll see if that'll change down in the
They
hill.
make it like 3% a roll like that.
So, point being, would you rather miss a whole class or would you rather be tardy?
Tardy.
Okay. I would rather have you here on time. Okay? Now, again, I know a lot of times I say this and people don't, they're like, whatever, but you won't keep a job if you are tardy all the time. Okay? So, again, it is a life skill to learn to be on time for things. Okay? Now, here's the other thing. If you're tardy, say 4 times for me, and then you can go a week or 2, show me improvement. You get a tardy, I'll call down and I'll tell them, hey, don't give them a detention. They improved. They slipped up this one time.
Right.
Okay.
I already teach you like that.
Well, again, then don't be tardy. We're talking about being tardy 4 times. I don't think I've been tardy in 27 years 4 times to the school. So, again, it's not that hard. Okay? You just got to be in class and on time. Okay? That's right. Certainly. Is leaving or? Okay. Okay. All right. Bye.
I said the same.
All right.
I hit the bar this time. I think that's a sign.
Okay, Zamira, you need to go down to attendance. Okay? You need to go to attendance real quick. They need to see you done. They just asked for you to come down there and they said to bring your stuff. So I don't know. They didn't know if you would be back or not. So, just so you know. Okay? So down to attendance, please. Okay? All right. So, joinpd.com, you should be looking at a pair deck, ladies and gentlemen. Let me give you the code that you're going to need for what we are going to do today. So hang on one second. All right, at joinpd.com, ladies and gentlemen, this is the code you need. You need this code, PMRSTM. 6-letter code that you type in, ladies and gentlemen, and then we can get going. Thank you. All right, couple of things real quick too, ladies and gentlemen. Number one, I updated your grades again this morning. So if there was something that you were missing, but you have turned it in, it should be in there. Okay? So it should now be an Infinite Campus. The only place to check your grade is Infinite Campus. Do not check the grades in Canvas. They are not your official grades. The ones in Infinite Campus are. Okay? Now, if there is something that is missing in Infinite Campus, but you did it in Canvas, please let me know and I will check and I will see why it's not transferring over for you. Okay? This is a new system for us this year as far as for me teaching with Canvas. So if it misses something, I don't want to take that away from you. I want to give you credit for it. So please double check. All right? All right. By the way, I did take a look at it. And remember I told you there could be a quiz tomorrow? There will not be. Okay? It'll be either Thursday or Friday. And after what we get through today and tomorrow, I will have a better idea of when the quiz is going to be. Okay? Now, the measurements and the things that we did the other day, those are going to be on the quiz. And by measurements, if I give you a unit, grams, what instrument measures in grams?
Weight scale.
No, not a scale, although it is close to that.
Balance.
A balance. A balance measures in grams or kilograms. Now, what does a balance or what does kilograms tell you? What type of measurement is that?
Mass.
Well,
Weight.
mass. Thank you. Mass. It took me a minute to process because I heard matter first, then I heard mass. Okay, so mass is correct. If I give you the instrument of a ruler, what type of measurement does it take? Length. What kind of unit would it be in? No, not in the metric system. What unit would length be in the metric system?
Distance.
I understand that length is a distance. What unit would it be in?
Oh,
It would be in meters. There they are up there, ladies and gentlemen. Those are the 7 base units. Okay? So again, those are something that will be on the quiz. And then also these things that we're going to talk about today, which are called sig figs. So we will get to that. All right. Before we get to what we are talking about today, sig figs, take the marker that is on your screen, ladies and gentlemen, and you are going to drag that red icon to the digit in this number that is in the tens place. So which digit? The 1, the 5, the 3, the 2, the 3, or the 6? Which of those digits is in the tens place on a number line? Yes, sir, Jonathan.
Wait, we have to answer or wait.
What you do is you take your icon on your screen and you drag it over the digit that you think is in the tens place. 1, 5, 3, 2, 3, 6. Okay. So we're a little bit all over the place here.
Oh.
The digit, ladies and gentlemen, that is actually in the tens place is the 5. Hundreds, tens. What place is this, Jonathan?
Wait, so those are just random numbers with like a dot in the middle?
No,
Because I thought it would be on the 2.
It's 153.
On this 2,
Yeah.
that is the tenths place, not the tens.
Oh.
There is a difference between the tens, 10 place, and the tenths, 0.1 place.
I know my job.
Like the TH.
Correct. The TH makes a difference. With the TH, those are after the decimal. Luis, do you want to get out of here on time? Or do you want me to have you stay later because you're talking in class and not paying attention? And then you miss your bus to your game and then you don't get to play.
I'm paying attention.
You asked
I know what you said. That's the tens. That's the tens.
What's the tens?
The 5.
Okay, good.
Yeah, and the tens is a 2.
Good.
Yeah.
So, which of these digits is in the tenths place? Take your cursor. All you have to do is drag it on top of the digit. The 1, the 2, the 3, the 9, or the 8. Now, this is not something that should be new to you. You should have learned this in math class a long time ago. Okay? We're still all over the place, though. Okay? So, what we should be seeing is 1 dot right on top of that 3. That is the tenths place. Now with the TH on the end, that means after the decimal. Your last chance here, ladies and gentlemen. Drag your marker to the digit that is in the hundredths place with the TH at the end of it. Hundredths. So which digit is in the hundredths place? Well, a little better. Correct answer is the second 3. Now, that whole thing that you are looking at right there is a number. That is a number. But what we are talking about is the digits within that number, and the 3 is the one that is in the hundredths place. Now, again, you probably have not been talking about places in math class for years. But every digit within a number has a certain place value within that number. And that is what we are going to start talking about today. So please open your EISNs, ladies and gentlemen. Your EISNs, and open them up to this slide. Slide number, on mine it's 31. I'm about to tell you what number it is on yours. Hang on one second. So in yours, it's slide number 30. So this is the slide that you should be on right now, ladies and gentlemen. Now, what we are looking at here is we are looking at some examples of measurements, just like you took yesterday in the lab. So we've got a measurement of 4.25 centimeters. We have a measurement of 1.268 grams. We have a measurement of 385 milliliters. And we have a measurement of 24 students. Now, 24 students is not really a measurement. It is a what? How would you find that there are 24 students in the class? What would you do? You don't use a ruler. You don't use a balance. What do? You count. But remember, amount of substance or mole is a measurement. So even if you are counting something, it will be a measurement. So what are the three things that are shown in every one of those measurements? Two are very obvious, one is not. Can you give me one of the obvious things that is shown in any one of those measurements? A unit. Good. What else? A number. So all measurements show three things. One, quantity or a number. I don't care which term you use. Okay? Quantity or a number. Technically, it's a quantity because it is describing something. A number would just be that, a number. Number two, there is a unit shown in every measurement. When you make a measurement in this class, every measurement will have a unit with it. And then number three, something that is a little bit harder to tell. Something that is a little bit harder to see. Every measurement has something called precision/uncertainty. Every measurement has precision/uncertainty. Now, I will bet that this is going to be a question on your next quiz. So, if I were you, I would not only type these into your notes, I would probably write them on my periodic table somewhere. But that is 100% your choice, ladies and gentlemen. By the way, if you are missing a periodic table, it is because I have collected two of them that were left here during fourth or fifth period at some point in time. Which one? There you go. Natalie had your name on this one, but you must have gotten a different one from me. That's fine. Not a problem. Okay? So, Brianna, here's your stuff. What you turned in. Yes, Manny, what can I do you for?
So I wasn't here yesterday. It looks like you guys did a lab call.
Yep.
Where's my damn
Yep. As soon as you open it up, Manny, I can go into it. I can take that old activity out and I'll put in a one for you that you can do without having to. I'll get it done at the end of the day. Or if there's time during class. I will take that one out. Don't worry about it. It will appear in the exact same spot, but it will be the alternate assignment that you can do. Okay? And you can do it without having to go in the back and do things that we did in the class. Okay? Brianna, no. Manny was the one who was missed. Zamira was the other one. So, okay. All right. Questions? Okay. Now.
Wait. You go back.
Okay. Now, anyone need more time? We're good? Okay. So what you are looking at here, ladies and gentlemen, is a slide that's going to explain the differences between a number and a digit to you. Okay? Now, this whole thing right here is a number. 1,342,365.1427. Now, This number is made up of 11 different digits. Each one of those digits is in a different place. So again, this is just a reminder about places on a number line. Just to the left of the decimal is the ones place. Then comes the tens, hundreds, thousands, 10,000s, 100,000s, and millions. And we could keep going. Okay, you could keep going. There is the 10 millions, there is the 100 millions, there is the billions place. On the right-hand side of the decimal, there are the ones that are smaller than 1. They all end in TH, and we begin with tenths, hundredths, thousands, 10,000s. Now, this is what we were talking about in the measurements yesterday. It is possible that you will have an instrument that reads to the tenths place. It is marked off between 1 and 2 centimeters, and you can see where 1.1 is, 1.2 is, 1.3. We had our meter stick the other day. That was marked off all the way to the thousandths place. You could see where 0.001 of a meter was on that meter stick. We had graduated cylinders that only read to the ones place. Okay? So every instrument that you look at reads to a different place. Now, the difference between a number and a digit is as follows. Number 1, a number is one value that represents a measured quantity. So when you take a measurement, you are going to write down a number and a unit. That number represents how much of something there is. How many grams, how many meters, how many liters, how many seconds. It is how much of something. But it is one single measurement. A number can have multiple digits, and most do. So a lot of the measurements that we make will have 3, 4, 5 digits in them, depending on what we are measuring. Not all, but most. A number can have a decimal in it. Now, every number has a decimal at the end. It just is shown in some numbers and not in others, correct? And I shouldn't say at the end, but if we write a number down like 316, well, there is no decimal shown. Where is it assumed to be? After the 6. Okay? So even though it's not there, that is where it would go, correct? If you have a number like 2.10, there's your decimal. It has to be shown. Not every measurement we make will you have a decimal in it. Okay? Numbers can go from 0 to infinity. Okay? And when you were a kid and somebody would go, I know the highest number possible, and they'd go infinity, and you would go, no, infinity plus 1. You can just keep going forever. Numbers don't have an end. Okay? Now, lastly, ladies and gentlemen, a number can be positive or negative. A number can be positive or negative. Can a measurement be negative? Can a measurement be negative? Name something we measure. Okay, so distance, right? Can you have a negative distance?
Yes.
How do you show minus 3 meters?
Would be walk back 3 meters.
But it's still 3 meters. It's in a negative direction, but the distance is 3 meters, correct? Can't have a negative distance, right? How about mass? Can you have a negative mass? Measurements cannot be negative. Now, the change in something, Manny, you are correct. The change in something could be a negative number. So you have lost 80 grams compared to something else. It is minus 80 grams. The measurement cannot be negative, but the change could be. So for example, if you talk about working backwards, okay, you can be 3 meters from where you started from. We normally don't say that's a negative 3 though, okay? Now, digits, ladies and gentlemen, digits are one single value within a larger number. Each one of these digits makes up this number, okay? They are one single value within a larger number. They are part of the number, if you will, okay? Digits represent one place within the number. What are the possible digits that you can have? Numbers go from 0 to infinity. What are the possible digits you can have?
Any
Such as?
1, 2, 3, 1 billion.
Yes, but 1 billion is not a digit.
Digit?
It's a number.
Oh yeah.
So what are the digits that you can have?
Like 19 12.
Okay, but when you put those together, that makes a number.
Yeah.
So what values can the digit in the tens place be?
Oh, 1 through 9.
What?
1 through 9.
Nope, you're close though.
0 through 9.
0 through 9. Digits have a value from 0 through 9. Now, if you get to 10, you then have what? Which is 2 digits, made up of a 1 and a 0. Digits can only be from 0 to 9. That's all they can ever be. Okay? You can have multiple digits within a number, but each individual digit is from 0 to 9. That's it. Okay? Digits do not have a sign. You will never put a negative in the middle of a number because you want that digit to be negative. It doesn't work that way. Your whole number could be negative, but not a digit within it. Okay? Hold on, sorry. I thought I had one more to do and it didn't, so I brought it back right away. Questions. So let's take a look at some numbers and see if we can figure out what the digits are and what place the digits are in. All right, so this first number, 403.602. How many digits are in that number, Marissa? How many digits are in 403.602? How many total digits? Count them. There are 6. 1, 2, 3, 4, 5, 6. There are 6 digits there. Okay. What place is the last digit, the 2, in? What place is it in? Cynthia. What place is that 2 in according to this number line? It is in the thousands. Now, I'm going to give you a little piece of advice here, ladies and gentlemen. I do not like writing out the word tenths. I do not like writing out the word hundredths. I do not like writing out thousands. And I really don't like writing out 10 thousandths. Writing these out is a pain in the butt because they are long. I am going to represent them with a number. To represent tenths, we can simply put 0.1. It would mean the same thing. How would we represent hundredths? Like what? Well, if this is tenths, this would be 0.01. Justino, what would thousandths be? 2 zeros followed by a 1. So Adeline, what would be 10 thousandths? Yeah. 3 zeros followed by a 1. Now, in chemistry, we very rarely use commas. Very rarely. Because a comma could accidentally be confused with a what? So we don't do it. But you may see people leave a space after 3 zeros so that represents 3 places, and now you're moving to the next. That is not unusual. Okay? Now if we go to the other side of the decimal, remember? These are to the right of the decimal. If we go to the left of the decimal, or up, we have the ones place. We have the tens. We have the hundreds. We have the thousands. Okay? So what would a numeric way to represent the ones place be? If this is tenth, what would this be?
0 before the period.
Okay. 1. How would we represent tens?
10. 100.
So if you want to do that instead of typing in the word in these, please feel free to. Okay? So instead of writing the word, thousandth, you can write 0.001. A little bit easier. Fair enough? Okay. Now, how many digits, Luis, are in this number right here? How many digits?
6.
Okay.
Perfect.
Okay.
Perfect. Now, what place is that last digit, the 5, in here, Jordan?
It's 1,000.
What?
The thousands.
Sure about that?
I got it.
10,000.
Okay, we're good with that?
100,000.
It's actually the 100,000s.
Mm.
And that's where, okay. Now, 1, 2, 3, 4, 5, right? 1, 2, 3, 4. The next one would be the 100,000s. Okay, good. All right, how many digits in the next number here, Leslie? 560,000. How many digits? 6. Okay. Now, what place is the last digit in here, Calvin? This number right here. What place is the last digit in?
The 1.
The ones. Very good. All right. Osmar, how many digits in the next number?
The tenths. Oh,
The tenths is how many digits there are? Do you see the number I'm talking about right there?
oh,
How many digits in that number? one on your screen. You should be on the same slide I am.
5.
5. Very good. Virginia. What place is the 5 in this number? That last digit, the 5, what place is it in? How many places beyond the decimal is that 5? Count them. How many places? Good. So here's the decimal, right? Count how many places until we get to the 5. 4. So now you come here. 1, 2, 3, 4. What place is that? That's the 10,000s place. Very good. All right, ladies and gentlemen, here's what I want you to do now. I want you to write a number that has 4 digits and ends in the ones place. 4 digits and your last digit is in the ones place. Yes, sir. When you get caught up, sir, you have all this typed in, I'll think about it. Yes, Francis. Yes. What? Okay. So, here's the question that I just got asked. How are you supposed to know how to do this? Well, let's begin with this, ladies and gentlemen. Give me any 4 digits, please. Any 4 digits, give them to me. 5, 6, 0, 5. Okay? There's 4 digits, correct? What place is this last one in? The ones. That's all you had to do. So, for this one, the lowest number that you could have written here was 1,000. What was the highest number you could have written? 9,999. Okay. So now, give me these same 4 digits, but that end in the hundredths place. How do I make this number end in the hundredths place? And I'm just asking you. I'm not asking you to write it down right now. How would I take this 4-digit number and instead of ending in the ones place, which it does, how would I make it end in the tens? Where would I add it? You're absolutely correct. Where do I add it to make this 5 be in the hundredths place? Okay. Where's the hundredths place? How many beyond the decimal?
2.
So where does the decimal have to go in here between what 2 numbers?
6 and 0.
So I would put the number there. What if I wanted to make it end in the tenths place?
0 and 5. No, wait, no. 5, 6. Right? No. Wait. 5.
Where do I put it?
Before the 5.
Before the 5?
No, oh no, wait. After 5. Hold on.
After the 5?
Yeah.
You got to be careful. I got 2 5s here.
Before, between the 5 and 6.
Let's get this straight. This was hundredths, correct? This one? Now, I want tenths.
1 and 4.
Nope, not between the 5 and 6.
Wait. 0 and 5.
Put it between the 0 and 5. Yes, man. Okay.
Are you gonna think about it?
Didn't I just give you permission?
I don't know. Just turn back to the whiteboard.
I'm sorry, I said okay.
Oh. Okay.
All right. Same number, 4 digits, correct? Okay. And I want the last. You can't do that. Never mind. We'll get to that. So, okay. So here, 7 digits with a number in the 100,000s place. How far beyond the decimal do you have to go to get to the 100,000s place? Nope. 100,000s is after the decimal. So we're talking, this was 10,000s here. How do we get to 100,000s? How many places? 5. 5 after the decimal. Okay. Here's the 10,000s, 100,000s would be next, correct? Okay. So I need a number with 5 digits after the decimal. But I need 7 digits total. So what does that mean I have to do before the decimal? 2 numbers. So what is the smallest number that you can write that meets those requirements? Smallest number that you can write that gives you 7 digits to the 100,000s place.
100 million.
Okay, but 100 million doesn't even get to the 100,000s place.
Wait.
We said 100,000s. You have to be how many places beyond this decimal?
100,000?
5. 5 to the right of the decimal. How many does that mean to the left? To get to 7 digits? 2. What is the smallest 2-digit number that you can write?
10.
10. We can't do 0 first, right? Because we wouldn't write it that way. We wouldn't do 0, 1, right? So, the smallest number that you can have that can go to the 100,000s place and have 7 digits. What is the smallest? Well, what would it be? We know what's before the decimal. How much? 2 digits. What are they? Smallest 2 digits you can write. What would be the 5 digits afterwards that would give us the smallest number you could make? All zeros. Correct? 7 digits here, ending in the 100,000s. What's the largest number you can write? Instead of 10, what would the numbers before the decimal be? 5? 9 what? We got to have 2. This could be a 9. What could this one be? So 99. Point what? Keep going. One more time, I'm sorry. You bet. You can't go any bigger than that number. Why? Next number moves up to 8 digits, right? All right, so write a 3-digit number that goes to the 10th place. So write 3 digits down, any 3 digits, and then make them end in the 10th place. That's not the 10th place, though. It's 2 after the decimal. The 10th is only on the decimal. 1. All right, who can give me an example? 3 digits. Last number in the tens place. Susan, can you give me one? 63.1. 3 digit ends in the tens place. You bet. Give me another. Normally. Give me 3 digits. Any 3 digits you want. Give me 3 digits. One, three, two. Where do I put my decimal so that that ends in the tens place? Between the 1 and the 3 and the 2, after the 2 or before the 1? Between the 3 and the 2. There you go. What's the smallest number we can write?
10.0.
10.0. What's the largest number we can write? 99.9. Okay? Okay? So if you can do this, ladies and gentlemen, you are starting to understand digits and you are starting to understand places. Questions? All right, wonderful. So that leads us to, ladies and gentlemen, is this. Significant figures. You took a bunch of measurements the other day. Every measurement that you took had significant figures in it. Significant figures are digits within a number that have meaning. Things that we measured. You went to the wall, you measured a brick. You measured the object on the balance. You got a bunch of numbers. How many of those numbers mean something? How many of they don't? Significant figure is any digit within a number or measurement that has meaning. Any digit within a number or a measurement that has meaning. The digits that you write down are called significant figures. By the way, I will abbreviate this sig figs or just SF. All mean the same thing. Significant figures include all known digits plus one estimated. So when you take a measurement, you got to write down everything you know, and then you get to estimate one place. Just like we were talking about yesterday, where Calvin writes down 7.63, Osmar wrote down 7.62, or I got that reversed, and then Luis came through and he did 7.60. We knew the 7, we knew the 6, you get to estimate that last place. Same thing here. That digit that you estimate is still called a sig fig. Okay. Non-zero digits are always significant. What are the non-zero digits, Manny? What are the non-zero digits? Good. So what's the only digit left? 0. So the only digit we ever question is a 0 in a number. Zeros in a number may be significant, they may not be. If it's not a 0, it's significant for sure. Okay? Significant for sure. Now, there are 3 places a 0 can occur within a number. You are in line for your favorite concert tickets. What are the 3 places you can be in the line?
Front, middle, back.
Front, the middle, or the back. Beginning, the middle, or the end. Those are the only 3 places you can be in line, correct? Okay. Well, where are the 3 places a 0 can be in a number? It can be in the beginning, it can be in the middle, or it could be at the end. It could be in all 3 of these because you could have multiple zeros. You can have multiple zeros at the beginning, multiple zeros in the middle, multiple zeros at the end. But zeros are the only number we ever question whether they are significant or not. And here are the rules, and it's based on where they are located. Now, all the zeros in all of these numbers are where? In the where? Front or the beginning. They all are in the beginning of the number. Now, how many zeros at the beginning here?
4,
4. How many zeros here?
2, 1, 1, 0, 2, 2, 2.
Okay. So they all have zeros in the beginning. Okay. All of the zeros at the beginning of a number are never significant. They don't count as sig figs. So there are 7 digits in this number. 1, 2, 3, 4, 5, 6, 7. But only how many of them are significant figures? Only 3. The 3, the 6, and the 9. So that's what sig figs are, ladies and gentlemen. Not every one of those digits is significant. Now, we need these zeros at the beginning to hold what we call the place. To get to the 10,000ths place here, we need these zeros in front. But they are not significant. Okay? They're placeholders. They are not significant. There are 6 digits here. How many of them are significant? 4. The 2, the 2, the 1, and the 5. How many of these 3 digits are significant here?
2.
The 3 and the 2. And how many of these 3 digits are significant? 1, the 6. That is it. That is the rule for zeros at the beginning of a number. Question. Okay? So where is the next place that zeros can be? Middle. Now, by the way, the middle doesn't mean exactly the middle. The middle means you're not at the beginning and you are not at the end. Okay? So 0 in the middle, 0 in the middle, multiple zeros, all in the middle. Zeros in the middle, zeros in the middle again. Zeros in the middle are always significant. Always. How many digits here? 4. How many of these are significant? All 4. All 4. 5 digits here. How many are significant? All 5. 6 digits here. How many are significant? 6. 5 digits here. How many are significant? Can't be more than 5.
4.
Nope. All 5. Now this 0, you're saying it's after the decimal, right? But it's still in where in the number? It's still in the middle. It's still in the middle. Okay? The only way you have zeros at the beginning is if your number starts out 0 point something. Those are zeros at the beginning.
So it could be any number.
What?
So if it's like a 3, it's still significant.
Correct. We don't, any number that's not a 0 automatically is significant. So the 2, the 1, and the 6, those are automatically significant. The question is, are the 3 zeros in the middle significant? The answer is yes. So the 2, the 6, and the 9, those 3 are definitely significant. How about the 2 zeros? So that gives us 5. How many in the last number? 6. Okay, 6. All right. Now, zeros might be at the end of a number. Now again, you can have multiple zeros at the beginning. You can have multiple zeros in the middle. Well, you can have multiple zeros at the end. These 2 zeros are at the end. Why? Because there's not a number in between them or after them that's not a 0. Here's the last non-zero digit. These are at the end. These are at the end. These are at the end, even though 2 of them are before the decimal and 2 of them are after. They're all at the end. And these are at the end. Now, what is in every one of these numbers besides the zeros and the other digits? A decimal. That is important because zeros at the end are sometimes significant. Sometimes. How do we know? Zeros at the end are significant when there is a decimal point shown. So if you're going to write a decimal point, it means that zeros at the end of your number become significant. They become significant. 32.00. How many sig figs in that number? How many sig figs in 32.00? Nope. Nope. All 4. Now, The 3 and the 2 are for sure, correct? Because they're non-zero digits. The question is, are these 2 zeros? The answer is yes, because there's a decimal here. The 1, the 2, the 3, and the 6 are all significant here, correct? How about the zeros? Is there a decimal in this number?
Period.
That's a decimal. That is a decimal. Decimal and a period are the same thing. You'll never write a period in the middle of a number, right? So, that period, or decimal, sorry, makes the zeros count. How many sig figs? 7. 7. Now here you've got 2 zeros before and 2 zeros after the decimal, right? All 4 of those zeros are at the end of the number, correct? Is there a decimal? Then how many sig figs? All 6. All 6. The last one, where are your zeros? At the end. Is there a decimal? So how many sig figs? 4. Now I realize that is a weird way to express 9,600. But we can put a decimal and not put a digit after it. That is okay in science. Questions? So that only leaves one option. If you have zeros at the end, but what's missing? No decimal. So now if you have zeros at the end and there is no decimal, they are not significant. So 3,400 has 4 digits. How many are significant?
2.
Only 2, the 3 and the 4. We don't count the zeros at the end if there's no decimal. How about the number 3 million? Only 1 sig fig. That's it. How about the number 210,000? Not 3.
Oh no.
2. The 2 and the 1. None of these zeros are significant because they're at the end.
So even if it's 10.
So then that's
It doesn't matter. They're at the end. Without a decimal at the end, they are not significant. I don't care how many of them there are. If you have a decimal, they become significant. No decimal, they are not. 8,960. 3 sig figs. 3 sig figs. Questions? Okay. If you go into Canvas, there is a significant figure worksheet here. When you open it up, ladies and gentlemen, this is what it looks like. Thought I could show you, but I can't. This is what it looks like. The number 1,005. Are there zeros at the beginning of this number? No. Now again, remember, zeros that are over here in front of the number, we would never write them unless it was the zeros here with a decimal, right? So are there zeros at the beginning? No. Are there zeros in the middle? Yes. Are there zeros at the end? So, no zeros at the beginning, zeros in the middle, no zeros at the end. How many sig figs?
2, 3, 5, 4.
1.
Slow down. Think about your rules. Zeros at the beginning, significant or not? No. So even if they're there, we don't count. Zeros in the middle, significant or not? Yes. Zeros at the end, significant or not? Sometimes. Depends on if there's a decimal. So these zeros are in the middle, correct? So are they significant? So how many sig figs?
0.
Nope. 4. Zeros in the middle are always significant. Always. Okay? So, beginning,
I get it.
no. Middle, yes. End, Sometimes.
I got it
No. Yes. No. 4. All right, this one. Zero's at the beginning. Zero's in the middle. Those two are in the middle. Zero's at the end. No. Okay. So, how many sig figs? Do we count zeros in the middle?
Yep.
So then 4. 4. Okay. So, worksheets due tomorrow, ladies and gentlemen. You could take this out. You can get this finished up. You can work on practicing.
Is it due tomorrow at 11:59?
It's due by the end of the day tomorrow.
Oh, cool.
But here's the thing. You've got 10 minutes to get it done right now and get it finished and then turn it in early, and then you have nothing to worry about.
That's what I'm trying to do.
Plus, if you have questions, I will be more than happy to come over and answer them for you right now. Okay? So let's go to work, ladies and gentlemen. Let's see what we get done.